Unit 3.4 mean deviation and coefficient of mean deviation. So guys, let's continue further in our discussion of measure of dispersion, where in this class we'll discuss about mean deviation and coefficient of mean deviation. So have you ever tried to understand how much data point deviate from the average? So in this session we'll explore the concept of mean deviation, which is a key tool in understanding data variability. So we'll compare it with the other measures like variance, standard deviation, and we'll see how choosing the mean or median impact your result. At the end of this topic, you will be able to explain the concept of mean deviation and its usage in measuring data variability, differentiate mean deviation from other measures of dispersion such as variance and standard deviation, compare the impact of calculation of mean deviation by using mean versus median method, as they are the central values in your mean deviation calculation.
Okay, now discussing mean deviation. Mean deviation is basically it is the arithmetic mean of the deviations of a series computed from any measure of central tendency. Where in the case of mean deviation, all the deviations what we consider as a positive because we use absolute measurement here. So mean deviation is basically it's arithmetic mean of the deviation of the series computed from any measures of central tendency. Either it can be mean or median or mode, where all deviations are taken as positive, where the signs are ignored here. Okay, so according to Clark and Swigert, we usually compute mean deviation about any one of the three averages, either mean, median, or mode. Sometimes mode may be ill-defined, as such mean deviation computed from mean and median would be much more better. Okay, median is preferred choice between mean and median. Whenever we are calculating mean deviation, computing mean deviation from median would be much more better than working on mean or mode. Okay, understanding mean deviation. So mean deviation calculated by any measure of central tendency is an absolute measure. And for the purpose of comparing variations among different series, a relative mean deviation is required, where the formula of coefficient of mean deviation is basically a mean deviation by a measure of central tendency. It can be mean or median or mode. Here, if the result is desired in percentage, then the formula of coefficient of mean deviation will be a mean deviation by measure of central tendency, which can be mean or median or mode into 100. Now, computation of mean deviation for individual series, we need to calculate the average values. It can be mean, median, or mode for the series. We need to calculate the deviation of items from the averages, ignoring signs, and this denotes by modulus sign. Like imagine if the deviation is d, so we have to find the modulus of d. Okay, and then we need to find the sum of this modulus, which is called summation of modulus of d. And then this summation of modulus of d is divided by the number of items, which will give you us the value of mean deviation. Okay, now consider numerical like here that we need to calculate the mean deviation from mean and median for the following data, and the data is given as 100, 150, 200, 250, 360, 490, 500, 600, 671. Also, we need to calculate the coefficient of mean deviation. So here, from the following data, first of all, we need to do the total sum of this data. Total sum of this data is 3321. And then since the total 9 datas are there, the average of that, which is the mean, is 369. Okay. And then for calculating the median, I need to arrange this data in ascending order. And when I arrange the data in ascending order, I will have 100, 150, 200, 250, 360, 490, 500, 600, 671. Okay. And then for finding the median, median is the middlemost value. So I need to find n plus 1 by 2 observation, okay, for the median. Okay, and since the total number of terms is 9, so the median here would be the fifth term. And the fifth term, when you are arranging this data in ascending order, the fifth term is 360. Okay, then once I got this value, okay, I got the value of mean, I got the value of median. Okay, then what I can do, I can find the deviation of each of this data from their average value, either mean or median, whichever method I follow. And then I have to take the absolute value. So absolute means I'll ignore their sign. So in first set of calculation of modulus of D, I'm considering X bar, means I'll find the deviation of each value from the arithmetic mean. And in second case, I'll find the deviation of each value from the median. Okay. So uh, here when I was doing my calculation, my mean was 369. The mean what I calculated here was 369. And when I did the median calculation by arranging the data in ascending order, okay, the median what I got was 360. So once I got this value mean as 369 and median as 360, okay, then what I'll do, I'll find the deviation of each value from 369 in the case of first set of column where I'm finding this value in the respect of mean, and then for median I consider the average as 360. Now 100 minus 369, okay, that I will do. Okay, then 150 minus 369 I'll do. Then 200 minus 369 I'll do, like this for the mean. And for median what I'll do 100 minus 360. Okay, then 150 minus 360, then 200 minus 360, then 350, then 250 minus 360, then 360 minus 360, then 490 minus 360, then 500 minus 360, then 600 minus 360, then 671 minus 360. That I will do. So, and we'll always consider the modular sign here, so that the sign does not matters to us. So when I do 100 minus 369, I'll get 269. Then 150 minus 369, I'll get 219. Then 200 minus 369, I'll get 169. Then 250 minus 369, I'll get 119. 360 minus 369, I'll get 9. Then 490 minus 369, I'll get 120 now 1. Then 500 minus 369, I'll get is 131. 600 minus 369, I'll get as 231. 671 minus 369, I'll get as 302. Sign is ignored here. Then the total sum of modulus of D, when I'm finding the deviation from arithmetic mean, I'm getting the sum as 1570. Okay, for the when the deviation is taken from arithmetic mean, then the total sum of D you will get as 1570. And then similarly, when it is done for from median, then the total sum will got as 1561. Okay, where we'll find the deviation of each value from the median. The median, as per our calculation, is 360. And when we did the total sum of the summation of D, by ignoring this sign, we'll got the sum as 1561. Okay. Now, when we'll find the mean deviation from mean, then the we'll find the average of the summation of D we got is 1570, and the n is basically 9. So the mean deviation from mean would be 174.44. Similarly, the coefficient of mean deviation here would be 174.44 divided by 369. 369 is your arithmetic mean. Okay, that calculation when we'll do, we'll get the value is 0.47. Okay. Then the mean deviation from the uh, from the median, when I'll do, this is mean deviation from median, not mean, corrected. That will get as 1561 by 9. That value will get as 173.44. And then coefficient of mean deviation by median method, when we'll do, the median was 360. So 173.44 divided by 360. When we'll do, we'll get the coefficient of mean deviation as 0.48. So when we have a discrete series, and if we want to find the mean deviation for the discrete series, first we need to find the average of the series, either mean, median, or mode, and then we need to find the deviation of variable values from the averages, ignoring the sign, and we denote it by the modulus of d. And then we need to multiply the deviation of each value by the respective frequencies, and we'll find out the total, which is your summation of modulus of FD. Okay, and then this value, the summation of modulus of FD, is divided by the total frequency, which will give us the mean deviation. Let's do a numerical to understand this. So here in this question, we have to find the mean deviation from mean and median method for the following data. Here, uh, the variables are given x is with height in centimeter, 158, 159, 160, 161, 162, 163, 164, 165, 166. So the height in centimeter is your x value, and the number of person is their frequency value: 15, 20, 32, 35, 33, 22, 20, 10, 8. That is the frequency value. So once we get this value, what we can do, uh, we can from this the height uh, in which is given in centimeter, that will be your x value, and the number of person or the frequency, uh, that would be our f value, and the total sum of frequency we are getting is 195. Okay, then for this question, what we need to do, we need to find here the d value. D is x minus a. I took a as 162. So just simplify the calculation, we use step deviation mechanism, where I assume an arbitrary value is 160, and in the step deviation method. Okay, and then what I did, I calculated the d value, where the d is nothing but your x minus your arbitrary value of 162. When I subtracted each value from 162, I got as -4, -3, -2, -1, 0, 1, 2, 3, 4. So that is my step deviation d value, that I multiplied with frequency f into d. Okay, and the total sum of that I got as -95. And then what we done here, uh, once we calculated this, okay, uh, then we can find the modulus of d. Okay, where d is your x value minus your mean. Okay, so first we have to find the mean here. Okay, first we have to find the mean here. So for finding the mean, we use this formula of step deviation formula called A is your assumed value plus summation of FD by N. Here the summation of FD we got as -95. So summation of FD we got as -95. Okay, and that will put into this formula. N is the total set of data, and A is your assumed value, what we have assumed as per this case. And then when we applied the formula, assumed value was 162, and summation of FD was -95. And N is basically the total sum of frequency. The total sum of frequency here is 195. The total sum of frequency is 195. Okay. So here when I applied the formula, so the mean value what I'm getting as 161.51. So the mean value what you got as 161.51. So the mean value what you got is 161.51. Okay. Now for finding the mean deviation, I need summation of f into modulus of d. And modulus of d, how will I get the modulus of d? From here in this column. So I got the mean value, right? Mean value I got is 161.51. So 161.51, I'll subtract from all x value, 158 minus 161.51, 159 minus 161.51, 160 minus 161.51, 161 minus 161.51, 162 minus 161.51, 163 minus 161.51, 164, 165. Like this I do for everything, and I ignore the sign. That will give my modulus of d. This modulus of D I multiply with the frequency. Frequency given to us is 15, 20, 32, 35, 33, 22, 20, 18, 10, 8. That I will multiply with the frequency, the modulus of D into frequency. And then the total sum of that, once we calculated, the total sum of F into modulus of D is 338.59. So this we got as total sum of F into modulus of D is 338.59 we got. Okay. So this when we applied in the formula, the total sum of F into D is 338.59. When we divided with the total sum of frequency of 195, we got the mean deviation as 174. And then the coefficient of mean deviation would be the mean deviation divided by the average value. The mean deviation is we got mean deviation as 1.74. This is 1.74 is not 174. It is 1.74, and that when is divided by the average x value, the mean value which is 161.51. We got the coefficient of mean deviation as 0.0108. Okay, now when we apply the median method, when we apply the first we did by the mean mechanism, now we'll do the same thing by median. So for working on median, we need a cumulative frequency. Frequency data, frequency and x values are given in the question. So from the frequency, we'll find the cumulative frequency 15, 15 plus 20, 35, 35 plus 32, 67, 67 plus 35, 102, 102 plus 33, 135, 135 plus 22, 157, 157 plus 20, 177, 177 plus 10, 187, 187 plus 8, 195. So we got the cumulative frequency here. And once we got the cumulative frequency here, what we need to do, we need to find, for the median, we need to find sum of f by 2. Now, for finding the sum of f by 2, how will we find sum of f? Sum of f is basically sum of frequency is basically 195 here. And 195 by 2, if we'll do, we'll get what? 200 by 2 is 100, right? So 195 by 2 would be 97.5. 97.5, we need to see the next value bigger than 97.5. And the value is 102, and the cumulative x value for that is 161. So the median here would be 161. So the median here would be 161. And once we got the value of median as 161, what you have to do, you have to find the deviation of each value from the median. So x minus median, a modulus you have to find means ignore the sign. 158 minus 161, 159 minus 161, 160 minus 161, 162 minus 161, 163 minus 161, 164 minus 161, 166 minus 161. Do that and ignore the sign. So that is your module D value. And then that D value, what we got multiplied with frequency. So we'll get F into summation of D, and total sum of that is 334. So 15 into 3, 20 into 2, 32 into 1, 35 into 0, 33 into 1, 30, 22 into 2, 20 into 3, 10 into 4, 8 into 5. That you do for each series, and total sum of that, sum of F into modulus of D is 334. So that will, when we divided by the total sum of frequency, which is 195, we got the mean deviation, and then the coefficient of mean deviation is nothing but mean deviation by median. So median we got as 161, and mean deviation is 1.74 or 1.71. Whatever you consider doesn't matter. You will get the coefficient of mean deviation as 0.0106. Another numerical, find the mean deviation from mean and median from the following series. Also compute their mean deviation. Here the class intervals, class interval with frequency is given to us. Whenever we are calculating on median, okay, then what we need cumulative frequency. For mean calculation, we can either apply sum of fx by sum of f, or we can use step deviation method like what we have done in the last class. So here, class intervals were given all in continuous in nature. Your x values are given to us. Okay. Then here, okay. So what we can do for mean calculation, we can find the mid value, which is called class mark of this class interval. A class mark is nothing but lower limit plus upper limit by 2, 0 plus 10 by 2, 5, 10 plus 20 by 2, 15, 20 plus 30 by 2, 25, 30 plus 40 by 2, 35. Like this, I can do for each class interval. Then frequency is given for each class interval. Okay, then if you are applying the mean deviation, if you are applying the step deviation formula, then we use a formula for like individual x value, the x value, whatever we got, okay, m or x value minus any arbitrary value divided by c. C is the class width. So here the c would be 10. So here the arbitrary value what I considered of m, I considered 35. So m 5 minus 35 is minus 30. Minus 30 when you divided by 10, you got as minus 2, minus 3. Then 15 minus 35 is minus 20. Minus 20 divided by 10 is minus 2. And like this, we'll find for each m value, and we got as minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Okay, those are my d value. Those d value when I multiply with f, I'll get f into d, and total sum of f into d would be given as 32 here. We got as 32. So once I get the sum of FD as 32, okay, my arbitrary value I considered here is 35. So the arbitrary value I consider 35, and sum of FD I got as 32, and total sum of frequency is 212, and the class width is 10. If I apply the formula, I'll get the mean as 36.5. So once I get the value of mean as 36.5, then what I can do, I can find the difference of each of the value from the mean. Okay, and the difference of each m value, that I'll find the difference from their arithmetic mean, and I'll consider the modulus of that. Okay, and then that is multiplied with the frequency. Okay, and then we'll get the value sum of f into modulus of d as 3193. Okay, so that value we got. Now for working on the mean deviation, we need sum of f, summation of f into modulus of d. That value we need, that when we divide by the total sum of frequency, we got the mean deviation. Total sum of frequency is 212. Okay, then so the summation of frequency into modulus of d is 3193. 3193 when it is divided by 212, we'll get the mean deviation. The mean deviation we got is 15.6, and then we can find the coefficient of mean deviation also, where we simply divide that mean deviation value what we got, the mean deviation value 15.6, when we divide by 36.5, that will give us the coefficient of mean deviation. Now, if you apply median method, so as I told you before also, and we have understood, I think by this time, that for median calculation, we need cumulative frequency. So once we get the cumulative frequency, then we have to find sum of f by 2. Sum of f is sum of f is what, 212. The total sum of frequency is 212. So total 212 divided by t, if you do, you'll get 106. Then you have to see in the cumulative frequency table, the next value higher than 106 is 117. So the selected class interval is 30 to 40. Your L would be 30. Frequency would be 40. Frequency of the selected class interval. One cumulative frequency before that would be 77. And then I'll find the median for this data. Then median is calculated. For median, what we need L we got is 30, M is 77, frequency is 40, class width is 10. And then when you apply the formula of median, okay, then we'll get the value here. The value what we got is 37.25. So the median what we got is 37.25. So once you got the median as 37.25, Once you got the median as 37.25, then what we can do, we can find modulus of D, which is the basically modulus of each M value minus the median value, means 5 minus 37.25. Okay, then you'll get 32.25. Modulus means ignore the sign. 15 minus 37.25, you'll get 22.25. 25 minus 37.25, you get 12.25. Then similarly, 35 minus 37.25, you will get as 2.25. Uh, 45 minus 37.25. Like this, you have to do for each case. And then whatever the sum of D we got, we have to multiply with F frequency. Okay. Then the total sum of that is 3209.5. Okay. The total sum of that is 3209.5. Okay. This value we consider for the mean deviation calculation. Okay, median till median we have calculated 37.25. Okay, then the mean deviation would be summation of f into d by n. Sum of f into d we got is 3209.5. Divide by the total sum of frequency as 212. So we got the mean deviation calculation as 15.1. Then the coefficient of mean deviation will be mean deviation by median into 100. Okay, so mean deviation already we got, median value also we got, so we can find the coefficient of mean deviation. Now discussing the merits and demerits of mean deviation. First, talking about the merits, it is simple to understand and easy to compute. It is rigidly defined. It is based on all the items. We basically taken all the items to calculate the mean deviation. So either we applied mean method or median method, we have taken all the data. Okay, that way it is good. It is not affected by the fluctuation of sampling, and it is affected by the extreme items. Okay, it is flexible because it can be calculated from any average, as you have seen. We have done more or less many numericals where we have calculated the mean deviation by mean method or median method, and everywhere we could easily to calculate. So that way it is good to work on. It is better measure of comparison. Talking about demerits, it is not a very accurate measure of dispersion. It is not suitable for further mathematical calculations. It is rarely used, not as a popular as standard deviation. Algebraic positive and negative signs are ignored here in the calculation. So mathematically, it does not look very sound, and it looks sometimes illogical also.
Let's summarize the concept what we have discussed so far in this session. So guys, when it comes to mean deviation, it is also known as mean absolute deviation. Okay, MAD. It is a statistical measure that quantifies the average distance between each data point in the data set and the central value, which is typically the mean or it can be median. Okay, when it comes to MAD, it provides an overview about data variability or dispersion, which indicates how spread out your values are from your center part. Here in this session we have discussed about mean deviation, how the mean deviation calculation through absolute differences between each data point and the chosen value are summed up, and we have discussed how totaling the total value what we got by the number of data point is ultimately gives us the value of mean deviation. Here we have discussed, like, unlike variance or a standard deviation, mean deviation focuses on absolute values, which make it less sensitive to extreme outliers. Here, when it comes to mean deviation, we have understood that it is straightforward and intuitive measure often used in exploratory data analysis. So I hope you have understood the concept of mean deviation, what we have discussed in this class. So it's time to wind up this session. Thank you everyone.